We're going to combine the function. The linear function f of x is x minus 3, and the square root function, the square root x plus 2. We're going to multiply them together. And so when we put them together, we get a function that looks like this: x minus 3 times square root x plus 2. And so we want to know what the domain of this new function is going to be. Well, we know the domain of this is going to be x is all real numbers. So everything's okay for that. Here the domain is going to be x is greater than or equal to negative 2. So the domain is going to be the most restrictive of the two. And so the domain will be x is greater than or equal to negative 2. So what do we know about this graph? Well, we don't know very much because we've never seen any graph like this. But we do know that it has some zeros. Okay, so we know that it has zeros at, since these are factors, we have zeros at x equals 3 and x equals negative 2. Where it starts, we're starting off at a 0. Now, what's the shape of this function going to be? Well, if we look at what we have essentially a degree 1.5 function. So this is somewhere between a linear function and a quadratic function. If I take a look at the degree here, it's 1. The degree here, the degree on the square root is 1/2, so this is degree 1.5. So the degree of this function is going to be 1.5. So the shape of this actually is somewhere between a linear function. It's going to be somewhere between a linear and quadratic. And when we actually graph this, and again, I don't really expect you to know what this graph looks like, but when we actually graph this function, what we do know is we have, it starts at negative 2, we have a 0 at 3, and it is going to go, and the shape is actually somewhere between a quadratic and a linear function. Okay, it's not quite symmetrical, it's asymmetrical. Maybe something like that. Okay? But it is, the shape is somewhere between a linear and a quadratic function. And we can start analyzing things in this way. Okay? So this is another new characteristic of functions that we can start using and helping us understand what the new graphs or unknown graphs are going to look like. So in this last example, we are putting a square root function over top of a linear function. So we want to know what are some of the key features are. Well, the biggest feature is when the denominator is equal to 0. So at x equals 3, we know there must be a vertical asymptote, okay, because we're dividing by 0. We also know that the domain of this is going to be x is greater than or equal to negative 2. In fact, since that's in the numerator, we know that there must be a 0 at negative 2. So what else do we know? Well, we know this is some square root function divided by a linear function. Well, if I take the limit of that, I have a square root over top of a linear function. So if I do the limit as x gets really, really big, of this quotient function, this is going to tend to 0 because the denominator is going to overpower the numerator. So we have an asymptote. It's going to go down to 0, something like that. And it is a rational function, so it's going to follow the asymptotes, and it's probably going to go down something like that. Okay, so this is what, from very little evidence that we have, we can maybe predict a graph might look something like this. And in fact, if you graph a square root function over a linear function, this is what it would look like. And again, we're just now starting to scratch the surface of analyzing functions that we don't know using parts of functions that we do know.